So we are going to try another problem where you are applying the remainder theorem. So if you watched the previous video, you would see that we actually ended up with our x value giving us 0. So it actually was a 0 of the polynomial. And so let's see what happens when that's not the case. So we are applying the remainder theorem to find f of 4. And again, you can plug 4 into your function and get your value, but it's not always the easiest to do by hand. And so what we can do is apply the remainder theorem using synthetic division to get our function value. So we are going to take 4 and then all the coefficients of your polynomial, being careful that you have all of your terms. So notice we don't have an x term, so we need 0 as a placeholder there. So -1, 8, 0, and 63. So again, that 0 there is as a it's a placeholder for x. So we need to be careful of that. Carry down that -1, multiply 4 times -1, add 8 plus -4, multiply, so 4 times 4 is 16, add, and then multiply 4 times 16 is 64, giving us a grand total of 127 right here. So your function value is equal to 127. So f of 4 is equal to 127. So you take the remainder right here, and that is your function value. So in this case, it's, I think, a lot easier than plugging in 4. And you'll see that with much more complex polynomials.